It's almost dizzying how quickly things move in the world of AI, isn't it?
Oh, absolutely.
You blink, and suddenly there's a whole new level of capability. Today, we're jumping headfirst into the latest wave, OpenAI's newly unveiled GPT-4.1 model family.
Yes, the 4.1 series.
We've got the details straight from their announcement. This was April 14th, 2025. And trust me, this isn't just another small update.
You're right. This feels like a real step change. OpenAI has introduced 3 new models. You've got the main GPT 4.1, then GPT 4.1 mini, and GPT 4.1 nano.
Right.
And the early information suggests some very significant performance enhancements across the board.
Exactly. We're not just talking about a slight edge over the previous GPT-4.0. These new models are claiming, well, comprehensive improvements. And what are the key areas they've been focusing on? Well, according to OpenAI, it boils down to 3 core pillars. A major boost in coding abilities. A much finer understanding of the instructions we give them, and then this capacity to handle truly massive amounts of information, what they're calling long context capabilities.
All right, the big 3.
So let's dive into each of these and see what makes them tick.
Let's start with the overarching picture, maybe. How do these new models stack up in terms of overall performance and, importantly, cost?
Got point.
What's interesting right off the bat is that OpenAI is saying the GPT 4.1 family not only outperforms GPT 4.0 and GPT 4.0 mini, but does so at a lower cost.
Lower cost and better performance. That's a pretty compelling value proposition.
It really is.
It really is. And for those listening who are developers, it seems like there's even more good news. They're highlighting improved performance at every point on what they call the latency curve.
Ah, yes, the latency curve.
Now, for those of us who aren't coding all day, what does that latency curve really mean in practice?
Think of it this way. The latency curve essentially describes the trade-off between how quickly you get a response from the AI and the complexity of the task it's performing. So what OpenAI is saying is that whether you need a quick, simple answer or you're asking the model to tackle something more involved, something that might take a bit longer, the GPT 4.1 family offers better performance at any given speed compared to the previous models, faster for the same quality or better quality for the same speed, basically.
That makes sense. So it's just more efficient across the board no matter how you're using it. Okay, let's dig into one of those core pillars then. Coding improvements. This is an area where they seem to be making some really, really significant progress, judging by the numbers they shared.
Absolutely. The scores on SWE Bench Verified are particularly noteworthy.
SWE Bench Verified. What exactly is that testing?
So this benchmark is designed to evaluate an AI's ability to tackle real-world software engineering tasks. Think like understanding a bug report someone filed for an existing code base, and then generating the correct code to actually fix it within that context. GPT 4.1 achieved a score of 54.6% on this.
54.6%. And for context, that's a substantial jump, right?
Huge.
We're talking about a 21.4% absolute increase over GPT-4.0's and even 26.6% over GPT 4.5. That's not just a small step forward. That feels like a leap.
It really is a leap.
What does that kind of jump in SWE Bench really tell us about what GPT 4.1 can now do that maybe the others couldn't or not as well?
Well, that jump really signifies progress in areas like understanding complex dependencies within a code base, generating more robust, less error-prone solutions. These have historically been significant challenges, even for advanced AI models.
Right.
It suggests a deeper understanding of the kind of intricacies involved in software development. It's moving beyond just syntax to more nuanced problem solving.
And it's not just about those headline-grabbing benchmark numbers either, is it? They're also talking about tangible gains in more specific coding scenarios.
Exactly.
Things like what they call agentic coding, where the AI takes more initiative, solves problems with less direct hand-holding.
Less step-by-step guidance.
Yeah. And also improvements in coding for user interfaces, what we often call front-end coding. Apparently, GPT 4.1 makes fewer unnecessary edits, sticks to requested diff formats more reliably,
which is important,
and is more consistent in how it uses various software development tools.
Yeah, that reliability with diff formats is actually quite important for developers using version control, like Git.
Explain that a bit more, the diff format thing.
Sure. So when you're making changes to code, you often just want to see the lines that have been added or modified. Right. That's what a diff shows.
Got it.
The fact that GPT 4.1 more than doubles GPT 4.0's score on Ader's polyglot diff benchmark and even beats GPT 4.5 by 8% absolute, that's a strong indicator of its improved ability to understand and generate these efficient change sets. And polyglot means across different programming languages.
Ah,
It just saves developers time and makes code reviews much cleaner.
right. And Aider is a tool that helps AI work with code repositories, I gather.
Exactly.
And that focus on diff formats, instead of just rewriting whole files, that seems much more practical for how people actually work.
Precisely. And let's not overlook the improvements in front-end coding, building the parts of websites and apps that users actually interact with.
Yeah, that seems really significant too.
The fact that human evaluators preferred websites created by GPT-4.1 over those by GPT-4.0 a whopping 80% of the time in head-to-head comparisons, that's a really compelling real-world signal of progress.
80%. That's pretty overwhelming. And the example task they gave it, creating a flashcard web app with features for creating, searching, reviewing, showing stats, all in a single-page React app. That's a non-trivial modern web dev task.
Definitely not.
So to have human graders so consistently prefer the output of the newer model, what do you think accounts for that? Is it better design, maybe more user-friendly interfaces, or just like cleaner code under the hood?
It likely involves a combination of factors. Could be GPT-4.1 has a better grasp of UI design principles, leading to more intuitive layouts.
Okay.
It might also be generating cleaner, more efficient code, resulting in a smoother user experience. But ultimately, that human preference suggests a more holistic improvement in its ability to create genuinely usable web applications.
And then we get to hear from the folks who've actually been using these models in their work, the alpha testers.
Right, the real-world feedback.
WindSURF, for example, reported a 60% higher score on their internal coding benchmark compared to GPT-4. Plus, it was about 30% more efficient in using other software development tools.
That's efficiency.
And around 50% less likely to repeat unnecessary edits. That sounds like a real productivity boost for engineers.
It absolutely does. Fewer redundant changes, more efficient tool use that translates directly into faster development cycles, and frankly, less frustration for engineering teams.
Less wasted effort. And Quoto's experience is also really interesting. They found GPT 4.1 provided better code review suggestions in 55% of cases compared to other leading models on GitHub pull requests. Now, for those who haven't been through a code review, why is that significant? Why are better suggestions important?
Well, code reviews are just a critical part of software development. It's where developers check each other's work for potential issues, ways to improve it, make sure it meets standards. What's fascinating about Quoto's finding is that GPT 4.1 apparently excelled in both precision, knowing when not to make a suggestion, which is just as important.
Right, avoiding noise.
Exactly. And comprehensiveness, providing thorough analysis when a genuine issue was detected. This suggests a more nuanced understanding of code quality, the ability to prioritize what actually matters. That's invaluable.
Okay, so it sounds like the coding front has seen some major advancements with GPT 4.1. Huge improvements there. Now let's switch gears and talk about how well it understands and acts on our instructions. Because even the most powerful model isn't very helpful if it can't reliably do what we ask it to, right?
Exactly. That's fundamental. And OpenAI is emphasizing the more reliable instruction following of GPT 4.1. They're noting significant improvements across various internal evaluations. They've even broken down instruction following into categories like adhering to specific formats, handling negative instructions like things you explicitly say don't do.
Okay. Like don't mention X.
Precisely.
Yeah.
Also following ordered steps, meeting content requirements, ranking different options, and even knowing when to say it doesn't know something, tackling that overconfidence problem.
That's a big one. And they specifically call out a significant improvement on what they're calling hard prompts within these categories. What makes a prompt hard, and why is improvement there so important?
Hard prompts likely refer to instructions that are more complex, maybe ambiguous, or ones that require the model to juggle multiple constraints at the same time.
Okay.
Improvement there is crucial because real-world requests are rarely perfectly clear or simple. A model that can better understand and execute on these tougher prompts is just going to be much more versatile and useful in practice.
Makes sense. And the ability to handle multi-turn instructions, where you have an ongoing conversation with the AI that seems really fundamental for a natural interaction.
Totally.
They mentioned a 10.5% absolute better performance on something called Scale's multi-challenge benchmark. What does that tell us?
So Scale AI's multi-challenge benchmark specifically tests a model's ability to maintain coherence and follow instructions across multiple turns in a conversation.
Right, remembering what was said before.
Exactly. So a 10.5% improvement suggests that GPT 4.1 is significantly better at remembering the context of a conversation and ensuring its responses are consistent with earlier parts of the chat. That's vital for building truly conversational AI agents.
And then there's iFeeble, where GPT-4.1 also scored notably higher than GPT-4.0. They describe iFeeble as using prompts with verifiable instructions. So it's almost like a test where there's a clear right and wrong answer based on the prompt itself.
Precisely. iFeeble is designed to assess how accurately a model adheres to the explicit requirements stated in the prompt. So yeah, a higher score for GPT 4.1 indicates it's just better at understanding and fulfilling those specific verifiable instructions.
And again, we see these benchmark improvements translating into real-world examples. BlueJay, who work in the tax software space,
Oh yeah, complex domain.
reported a 53% higher accuracy rate on their internal benchmark of challenging real-world tax scenarios. That's a huge jump in understanding complex regulations.
It really highlights GPT 4.1's improved ability to not just process text, but to truly comprehend complex domain-specific information and apply it correctly based on instructions. For BlueJay's users, that likely means much more accurate and reliable tax-related advice.
You'd hope so. And then there's Hex, a data analytics platform. They saw nearly a twofold improvement on their most challenging SQL evaluation set.
Wow, double.
That's a massive leap in understanding database queries. What was particularly noteworthy there?
What was significant with Hex, according to the announcement, was the improvement in both instruction following and what they call semantic understanding. Particularly the model's ability to select the correct tables from potentially ambiguous database schemas.
So figuring out which data to even look at.
Exactly. It suggests GPT 4.1 is not just better at understanding the SQL syntax, the code itself, but also the underlying meaning and relationships within the data. That leads to more accurate and effective data querying.
That's a critical point. Often the difficulty isn't just writing the code with the SQL query, but having a deep enough understanding of the data structure to even know which tables to pull from.
Precisely.
And they also mentioned a tip for prompting GPT 4.1. Be very explicit and specific, because it might interpret your instructions more literally.
That's an interesting nuance, isn't it? It suggests that while it's better at following instructions, it might also rely more heavily on the precise wording you use.
So less mind reading, more careful prompting needed, perhaps.
Could be. Clarity and detail in your prompts might be even more important to get exactly the outcome you want.
Okay, so better at understanding and following instructions, that's a big check mark for GPT 4.1. Now let's move on to what sounds like one of the most transformative advancements. The ability to handle incredibly long sequences of text, these long context capabilities.
Absolutely. This is potentially huge. We're talking about a context window of up to 1 million tokens.
1 million tokens.
For all three new models. GPT 4.1, the Mini, and the Nano.
Wow, even the small ones.
Even the small ones. To put that in perspective, the previous GPT 4.0 models maxed out at 128,000 tokens.
So roughly an 8x increase.
Yeah, it's massive. They even mentioned it's like being able to feed the model more than 8 copies of the entire React code base.
That's hard to wrap your head around. What kind of new possibilities does that open up?
I mean, imagine feeding an entire book or a huge legal case file or a complete software project into the AI and having it understand the entire thing in context. It feels like a real unlocking of potential for dealing with really complex, large-scale information.
It really does.
But what's crucial here isn't just the sheer size, right? It's the model's ability to actually use that vast amount of information effectively.
Good point. Can it actually pay attention to all of it?
Well, OpenAI is claiming that GPT 4.1 can reliably access and process information across that full 1 million token length. And they say it's significantly better at identifying relevant text while ignoring irrelevant distractions, whether the context is long or short.
And they've got some interesting ways of testing this, right? They talk about something called the needle-in-a-haystack evaluation.
Yeah.
Sounds pretty straightforward.
It is, conceptually. Essentially, they insert a single specific piece of information, the needle, somewhere within a very large body of text, the haystack,
Okay.
and then they just ask the model to retrieve it. The key finding is that GPT 4.1 consistently succeeds at finding that needle accurately, no matter where it's placed within that 1 million token context.
So it doesn't suffer from that lost in the middle problem.
Exactly. That's been a known issue with some other long context models where they struggle to remember or access information buried deep in the middle of a very long input. Overcoming that seems like a real breakthrough.
Definitely. But they also acknowledge that real-world information retrieval is often more complex than just finding a single needle, right?
Sure.
That's where this new OpenAI MRCR evaluation comes in. What's that all about?
Right. OpenAI MRCR. It stands for Multi-Round Coreference. It's a more sophisticated test designed to evaluate the model's ability to find and, crucially, distinguish between multiple related but slightly different pieces of information, multiple needles, if you will, within a long context.
Okay, so finding and telling apart similar things.
Yes, and also testing its ability to understand and track references to these pieces of information across multiple turns of a conversation. The scenario they describe, like a user asking for several similar but distinct snippets of writing from a large document, really highlights the complexity this evaluation aims to capture.
So it's not just about finding one thing, it's about understanding the nuances between multiple similar things within a huge amount of text and tracking them. How did GPT-4.1 do on this harder test?
They found that GPT-4.1 outperforms GPT-4o at context lengths up to the previous max, 128K tokens, and maintains strong performance even when pushed to the full 1 million token limit. They do note that even for advanced models like this, it remains a challenging area.
Understandable.
But the results are still very promising compared to what came before.
And they're also introducing another evaluation called graph walks. What's the focus there? Sounds different again.
Yeah, GraphWalks is designed to evaluate multi-hop long context reasoning. Think of it as needing the model to make multiple logical connections, or hops, between different pieces of information scattered throughout the long context.
Connecting the dots across the document.
Precisely. It's not just finding a specific fact. It's about following a chain of reasoning across different parts of the text to arrive at an answer. GPT 4.1 achieved an accuracy of 61.7% on this benchmark.
And how did that compare?
Well, they say it matches their internally very strong O1 model, which we don't know much about publicly, but importantly, it beats the previous GPT-4o.
So it's not just about remembering information across a long span. It's about being able to reason across that vast amount of information.
That seems to be the key takeaway.
Okay, benchmarks are helpful, but again, what do these long context improvements mean for actual users? Any examples?
Yes, the real-world examples from their alpha partners paint a compelling picture here too. Thomson Reuters for their co-counsel AI assistant used in legal research.
Right, for lawyers.
They saw a 17% improvement in multi-document review accuracy when using GPT 4.1 compared to GPT 4o on their internal long context benchmarks.
17% improvement in accuracy.
Yeah.
That sounds significant in law.
It really does. It means the AI is significantly better at maintaining context across multiple lengthy legal documents and identifying those subtle but critical relationships between them. That could be a game changer for legal professionals.
Absolutely. Being able to synthesize information from numerous sources, spot those connections, that's huge. And then Carlyle, a global investment firm.
They reported a 50% better performance on retrieving specific financial data from very large documents.
50%?
Yeah. And they specifically highlighted that GPT 4.1 was the first model that could reliably handle these massive documents without getting lost in the middle or struggling with complex reasoning across different sections, things that limited previous models.
Wow. That's huge for the financial industry, too, where analysts often have to sift through enormous reports to find key insights.
Definitely. The ability of GPT 4.1 to handle these large contexts effectively could lead to significant gains in efficiency and accuracy there.
And it's not just about handling more data, is it? They've also worked on speed and cost effectiveness for these longer contexts.
Exactly. They've optimized their underlying technology, what they call the inference stack, to reduce the time it takes for the model to start generating its response, the time to first token, especially for these longer inputs.
Okay, faster startup.
And they've also significantly increased the discount on prompt caching. That's basically reusing computations from previous similar requests. So if you're working with similar long documents repeatedly, that can further bring down costs and latency. Up to 75% discount now, they said.
75% discount on caching. That's substantial. And what about actual speeds? Did they give numbers?
They did give some typical figures. For the main GPT 4.1, the 95th percentile latency, meaning 95% of requests are faster than this, is around 15 seconds to get the first bit of output for a 128,000 token input.
Okay, 15 seconds for 128K.
And that can go up to around 30 seconds for the full 1 million tokens.
30 seconds for 1 million tokens to start responding. Still pretty impressive scale.
It is. And interestingly, the smaller models, Mini and Nano, are even faster. They mention Nano often delivering that first token in under 5 seconds for a 128,000 token input.
Under 5 seconds for Nano at 128K. So they're really catering to different needs in terms of speed, cost, and scale across the family.
Seems like it, a tiered approach.
Okay, so massive improvements in handling long context. Now let's touch on another area where AI has made huge strides recently. Understanding images and videos, the vision capabilities.
Yes, the GPT-4.1 family appears to be making notable progress in this area as well. They're highlighting exceptional image understanding capabilities across the board. And GPT-4.1 Mini, the smaller one, showed particularly impressive gains here. It's even outperforming the previous flagship, GPT-4o, on several established image understanding benchmarks.
The Mini is beating the old flagship on image tasks.
Right.
Which benchmarks?
Things like MMMU, MathVista, and chunks of reasoning.
Okay, for those of us not living in benchmark land, what do those tests?
MMMU tests multimodal understanding across a wide range of subjects, needs to integrate info from images and text. MathVista focuses on visual reasoning in math problems.
Right.
And chunks of reasoning evaluates the ability to reason about characters and diagrams, often in scientific papers.
Got it.
The fact that GPT-4.1 and especially the Mini are doing better on these suggests improved capabilities in visually grounded reasoning. The scores they reported were in the mid-70s% accuracy for 4.1 and Mini on MMMU and MathVista.
Mid-70s.
Which is significantly higher than GPT-4o scores, which were more like high 60s and low 60s, respectively.
That is a significant jump, particularly for the smaller Mini model beating the previous top model. And it's not just static images, right? They're also seeing improvements with video.
That's correct. They're reporting state-of-the-art performance on a benchmark called Video MME for long context multimodal understanding, specifically tested on long videos that don't have subtitles.
Okay, understanding video without text help.
Yeah. GPT-4.1 achieved an accuracy of 72% on this, which is a noticeable improvement over GPT-4o's 65.3%.
So it's getting better at understanding not just what's in individual frames, but also what's happening over time in a video, even without subtitles.
Yeah.
That's crucial for things like video analysis, understanding complex events. Now, let's delve a bit more into those smaller models, GPT-4.1 Mini and Nano. It sounds like they've really optimized these for specific use cases, beyond just the vision improvements for Mini.
Absolutely. GPT 4.1 Mini is being positioned as a really significant step forward in the performance you can get from smaller AI models.
Smaller but mighty.
Kind of. They're even claiming it can match or exceed the intelligence of the previous top-tier model, GPT-4o, on many evaluations.
Wow.
While reducing the latency, the response time by nearly half, and cutting costs by a remarkable 83%.
83% lower cost. With nearly half the latency and potentially GPT-4o level intelligence, that makes it a very attractive option.
Extremely attractive for applications where speed and affordability are paramount.
What kind of applications might really benefit from that specific trade-off?
Oh, think of things like real-time customer service chatbots, interactive educational tools, maybe even some on-device AI processing where you need fast, efficient responses without heavy cloud reliance.
Right, edge computing perhaps.
And the lower cost just makes it more accessible for a wider range of developers, smaller companies, startups.
That's a good point. And then there's GPT 4.1 Nano. They're calling it their fastest and cheapest model yet. What's its sweet spot?
So GPT 4.1 Nano, even though it's incredibly small and low cost, it still boasts that impressive 1 million token context window.
Still 1 million tokens on the Nano. That's surprising.
It is. It's really designed for those ultra-low latency tasks, things like content classification, maybe auto-completion suggestions as you type, or quickly extracting very specific, simple pieces of information.
Because speed is the absolute priority.
Speed and cost. But despite its small footprint, it still achieves pretty impressive scores on some benchmarks. They mention MMLU for general knowledge, GPQA for tough professional questions, and it even outperforms the GPT-4o Mini on that AIDR polyglot coding benchmark we talked about earlier.
So the new Nano beats the old Mini on coding diffs. Interesting.
Yeah, it packs a surprising punch for its size and speed. It's a lot of capability packed into a very efficient model.
It really does sound like they've created this tiered system, doesn't it? Catering to a whole range of needs, from raw power and massive context with the main 4.1, down to sheer speed and cost-effectiveness with Nano, and Mini somewhere in between.
That seems to be the strategy. Provide options.
And all these advancements, especially in understanding instructions better and handling these huge, long contexts, they must have significant implications for building more sophisticated AI agents, right?
Oh, absolutely. That seems like a major driver. The improved reliability in following instructions, the ability to maintain context over much longer interactions, that makes the GPT 4.1 models significantly more effective at powering autonomous agents.
Agents that can do more complex things.
Exactly. Agents that can now handle more complex multi-step tasks. Think areas like software engineering assistants, like we discussed, or extracting detailed insights from vast amounts of documents, providing more nuanced and genuinely helpful customer support. All with less need for constant human oversight.
Less hand-holding for the AI agents.
Precisely.
And for those of us who are using ChatGPT day to day, it sounds like we're already starting to see some of these benefits trickling down, even if we're not directly calling the API.
That's right. OpenAI mentioned that the latest version of GPT-4.0 in ChatGPT is already incorporating many of these underlying improvements from the 4.1 development.
Okay.
And we can likely expect to see even more of these new capabilities rolled out in the user-facing product over time. It's not just API users who benefit eventually.
Good to know. And one final practical note for developers who might still be using the previous preview version of GPT 4.5 in the API. There's a heads up about a transition coming up.
Yes, important deadline. OpenAI has announced that GPT 4.5 preview in the API will be deprecated on July 14th, 2025.
July 14th, so soon enough.
Yeah, and the reasoning is straightforward. GPT 4.1 just offers comparable, or in many cases, better performance at a lower cost and with lower latency. It basically makes 4.5 preview redundant.
Makes sense. Upgrade to the better, cheaper model.
Exactly. It's the clear superior choice for most applications now.
So to kind of bring it all together then, we've seen some truly remarkable progress with this GPT 4.1 model family.
Right.
We're talking substantial enhancements in coding.
Huge gains there.
More reliable and nuanced instruction following.
Much better understanding.
A game-changing expansion in the capacity to understand and process long sequences of information, that million token context.
That's a big one.
And impressive strides in vision capabilities too.
Yeah.
All while apparently being more cost-effective.
It's quite the package, and the availability of these models through the API, including those specialized nano and mini versions, really provides developers with an incredibly versatile toolkit.
Right.
They can build the next generation of intelligent applications really tailored to a wide array of specific performance and cost requirements now.
It really does make you think about the future, doesn't it?
Yeah.
I mean, with these kinds of rapid advancements in AI capabilities, how might the tools and workflows we rely on every day be fundamentally reshaped?
It's a constant question now.
Yeah. What new possibilities might now be within our grasp thanks to these increasingly powerful and efficient models? It's definitely something worth pondering as you go about your day.